Hello and welcome to part 1 of Dev Maths and Statistics Refresher Course Lecture 7. The main focus today is probability, but we're going to start with a look at summation notation, because whenever you want to check some theory in a textbook, you'll find it's very often full of this kind of thing. So it's very hard to understand the justification for a lot of arguments in probability and econometrics and statistics generally without understanding this. And normally the lecturer will just write this on the board, and it's handy if you know exactly what they're referring to. So what I've done is I've got some variables here. So I've got variables of xi and yi, and I've also got a table or a matrix of variables of z, so zij. So if I refer to x3, I mean this one here, 27. If I refer to y10, I mean 50.3. If I refer to Z49, that's 690. And these are asking you to find the sum of certain values of x, y, and z, and combinations of those values. So what we'll do is we'll just work out these 5 sums. So as always, what you should be doing is, as you go along, try and pause it and go ahead, work out what the answer should be, and then play the video, either to check your answer or if you're stuck. To make it more practical, I've also provided these numbers, the same things, in Excel form, so to save you tapping it into a calculator. So what I'll do is I'll show you how to get these sums out of the tables of values here. So first one is number 1, and the way to read this is the sum for I equals 1 to 20 of xi. So, in other words, what you have to see when you look at that is just a really clever shorthand for x1 plus x2 plus x3 plus all the way up to x20. That should be a dot. So x1 plus x2 plus x3 all the way up to x20, just written in a nice short form like this. So that's what we're going to try and find out. And hopefully that one, it'll be a very easy start. So if we go to Excel here, let's write down some answers. We need a bit of space, so that's the answer to 1. And you can just use this command sum, and it's values from x1 to x20, so it's basically all the values. So 786. So that first one is just asking you to add all the values of x from 1 to 20. Okay, let's move on. So this one here, I equals 4 to, the sum from I equals 4 to 16, that's worth writing out a bit more, in a bit more detail. So I'll write the next few out so you can see how the logic of these. They're not so straightforward as the first one. Go to our friendly whiteboard. Oops, let's do that. That's what I wanted. So first difference here is that we're looking at y. Second difference is that we're not going from 1 to 20, we're just starting at 4 and going up to 16. So we want y4 plus, and then plus y5, oops, y5, and then plus all the way up to y16. But that would just be summing yi from 4 to 16, but also multiplying each one by 3. Up to 3. So it's 3 times y4 plus 3 times y5 plus 3 times y6 up to 3 times y16. So to calculate this, what I could do on the spreadsheet is put in another column here, 3yi and that would be multiply them like this, up to the top, and over here, question 2. So this is, over here we have 3yi, and I'm going to sum them from 4, the 4th one, up to the 16th one inclusive. Okay, so you get 511.8. However, that's probably not the quickest or the neatest way of doing it, because it's probably quicker to notice that, in actual fact, we could take this out as a common factor, because every single element is being multiplied by the same constant plus y16. So what I can do is just add up the original y's and then multiply by 3 at the end. And there's a point to showing you that, which is this thing here. You'll see this all the time in textbooks and proofs and so on. You'd very often just grab this 3 and take it right outside the summation. Oops. You wouldn't automatically write it in terrible handwriting, but you'd. So I equals 4 to 16, that's supposed to say yi. So whenever you see something as a constant, it could be actually written as a constant, or it might be like a variable ABC or something, which is just a scalar. You can take that outside and just do the summation like this. So anyway, just to show you, get the same result back on the spreadsheet. Obviously you will, but so what I would I do is this. I do equals sum and just get the original values of the y, wherever they are. So these, so 16, and then I'd multiply that by 3. And you get the same thing. So really there was no need for this extra column, so I'm going to zap that extra column because it's getting in the way, which means this goes back to 0, because that's no, not that. Okay. So that's number 2, 511.8. Okay, let's actually find the way back to the notes. Okay, here's the notes. Okay, this is another one where it's worth thinking a bit about how to simplify it first before you just go ahead and do the calculation. So what I'm going to do is transfer to our local whiteboard. Try to press the right button this time, and this is number 3, I think. So that's the problem. Okay, a bit larger. And first of all, you've got to comprehend what on earth, what is going on here. What does this mean? So we're going from 1 to 20. So the first one we're talking about is x1, but it's not just x1, x2, x3. Every time you pick out one of these x's, you're going to have to square it, and then you're going to have to take away 1,000. Okay. Then you're going to go to x2. You're going to square x2, take away 1,000, and then you're going to go on to x3, x4, x5, x6. Keep on going until you eventually come to x20. You're going to square that and take away 1,000. Or whatever that number says there. It's supposed to be, it should say 1,000, but it's my own style of 1,000. Okay. So again, what you could do, you could make a column, and in that extra column you're kind of going to create x1 squared minus 1,000, add it up all the way down. That would work, but the point is to see now what's going on with this thing. Can we just simplify this a bit and make our life easier? And what you should be able to see is that kind of these thousands here, how many lots of thousands you're going to get here, and the answer is you're going to have this like this, 1 squared plus x2 squared plus all the way up to x20 squared. So you're going to have all those squared things, but then you're going to have to take away 20 lots of 1,000. No, it's just 20 lots of 1,000, because there are 20 lots of 1,000 here. 1000. Yeah. So you can add the thousands together and subtract those at the end. Which means that if you want to look at how you might simplify this thing here, if you saw that in a textbook, then the next line might be, hey, we're going to simplify this. So actually we just got sigma, it's called sigma, by the way, I should have said that at the top. Sigma, and it's a Greek letter, capital S, and they chose sigma because sigma S for sum, so it's summation. So I from 1 to 20 of xi squared, from the x, the I in a strange place there, and then take off 20,000. So just be careful here, and this 20,000 is now, it's outside that summation, it's not connected with the summation where it's just a fixed constant on its own. You've taken it completely out, you've done the summation just by multiplying. So you have to make sure, if you have a constant, you can remove that from the summation, but you just got to multiply it by however many terms there are. Here it's pretty obvious, you have 20 terms. If we're doing it up here, we have to be a bit careful, because here we got what? 13 terms, I think. Think about it carefully, yeah, 13 terms. Okay, so unfortunately, we can't simplify it much more because we still have to add these things up. And here, there's no real way around this. We're going to have to, this time, insert an extra column. Like so. So we're going to need an x squared column. And that's going to be these values. Oops. To the power 2. So that's xi squared. So we've got x1 squared, x2 squared, all the way up to x20. And now it's quite easy to do our answer to 3, because answer 3 is the sum of all those xi squareds from 1 to 20, subtract 20,000. Yeah, I'll type too many O's, that's right. No. 15,822 would be the answer for that. Okay, so far so good. Where's the next question? Here it is. Okay. So I think, looking at the time on the clock, seeing that these are a little bit more complicated, I'm going to take a break here and go on to the next two in the next video. So thanks for watching.